Okay, today we're going to be talking about square roots. In your learning target, you can evaluate and estimate square roots. Today we're going to focus on the evaluating part though. There's some vocabulary words that are critical for you to be successful with this. We're going to get into rational numbers. A rational number is a number that can be written as a fraction. If you can write something as a fraction, it is rational. If you can turn something into a fraction, it's rational. Irrational number is the more complicated identification. Irrational numbers, there's just a few that are irrational. One irrational number is anything that is not a perfect square root. Not square. Anything that's not a perfect square root. A decimal that doesn't end, so that means like pi doesn't ever end, or have a pattern. Okay, we're going to get into rational and irrational in a couple lessons, so I just want to briefly define it for you, and then we'll engage more with it later. You need to know square root. A square root is a number when multiplied by itself gives you the number inside. So a number when multiplied by itself gives you the number inside the square root. Square root looks like this symbol. That's the square root symbol. So let's do a few examples. The square root of 4. So I'm asking myself, what number times itself gives you 4? And I know that 2 times 2 gives me 4, so 2 is the square root of 4. The square root of 25. What number times itself gives you 25? Well, I know 5 times 5 is 25, so the square root of 25 is 5. The square root of 121. What number times itself gives you 121? 11 times itself gives you 121. So the square root of 121 is 11. So that's evaluating square roots. Let's look at the questions here. It says, describe how to tell what the square root of a number is. And you should be scaling yourself here. Do you think you can tell how to evaluate the square root of a number? And that's when I asked myself, what number times itself gives you the number inside? All right, let's bump up the rigor a little bit, the difficulty level. And this is kind of a fun one, taking the fraction square roots. I love it because it looks super complicated, but it's nice and easy. You want to take the square root of, square root of the top, take the square root of the bottom, and then you simplify if you need to. Okay, let me state that again gracefully. To evaluate, this is part of evaluating. To evaluate a fraction square root, you're going to take the square root of the top number. You're going to take the square root of the bottom number, and then you simplify if you need to. So square root of the top, square root of the bottom, and simplify. All right, I think that sounded a little more graceful. Let's look at an example here. The square root of 9 over 36. This is equal to the square root of the top over the square root of the bottom. Well, the square root of 9 is 3. The square root of 36 is 6. And then you simplify. And I don't have much room, but that simplifies into 1/2. So I took the square root of the top, I took the square root of the bottom, and then I simplified. Let's do it again. Again, so a nice and easy strategy. It looks super complicated, but they're both perfect squares on the top and bottom, so I can quickly evaluate it. The square root of 16/9 is equal to the square root of the top over the square root of the bottom, which is, square root of the top is 4, square root of the bottom is 3, And then as 7th graders, we turn it back into a mixed number, 1 1/3. So square root of the top over the square root of the bottom, simplify. 3 steps. The square root of 25 over 144 is the square root of the top over the square root of the bottom, which is 5/12. Simplify if you can. We don't need to simplify 5/12 because it's already simplified. Okay, getting into our last 3 examples here. Square root of 1/4. I like this one because a lot of kids mess this up. So, square root of the top over square root of the bottom. The square root of 1, so what number times itself is 1? It's 1. Over the square root of 4 is 2. Final answer, 1/2. The next one, square root of the top over the square root of the bottom. Square root of the top is 10. Square root of the bottom is 5. Now I need to simplify it. 10 over 5. Remember, a fraction is division. 10 divided by 5. 2. That's your fully simplified answer. Okay, this next one is actually an irrational number, and I'll show you how I know that. When I do the square root of the top over the square root of the bottom, well, the square root of the top is 6, but the square root of the bottom, I don't know what number times itself gives me 2. That is not a perfect square root. That is not a rational number. Anything that's not a perfect square root is not a rational number. So you would just leave it like this, and this is not part of our learning target today, so this example just kind of snuck in here somehow. This is actually an irrational number. But your homework will be on the perfect square examples. Okay, and then we're going to bump it up again. We're going to apply it to real life examples here. So, if we want to find a dimension given an area, the only thing you need to do, this is given the square area. It's contingent that the area is a square. What you do to find the dimensions or the side length is you take the square root of the area. If you want to make it look easier, you can do side length is equal to the square root of the area. All right, here's an example. An area is 121 square feet. How long is a side length? Well, what I know about a square is they are the same, the length and the width is the same. So I want to know, and I know to find the area, you multiply the sides. Well, I know that the area is 121, so I want to know what number times itself is 121. So then my side length, or x in this case, I'm evaluating as x, is equal to the square root of 121, which is 11. Now that's the worked out example that you don't need to think of it that way, but I wanted to talk you through it. Again, the area of a square, you multiply its side lengths. They are the same, so I called it x. I know that the area is 121. So x times x is 121. What is x? Well, I'm asking myself, what number times itself gives you 121? So I took the square root, which is 11. Okay, this is another one that's an irrational number. So let's turn this 53 into something easy to work with. Let's make it, let's see, 64. So an area is 64 square inches. How long is the side length? Now let's use our nice, easy mini formula here and say the side length is equal to the square root of the area, which is the square root of 64. The side length is equal to 8. I like this way the best. It's fast, it's efficient, and I don't have to use a lot of letters. Okay, the next one, a word problem example. The area of a square square garden is 144 square feet. How many feet is the side? I'm going to use the formula we made. The side is equal to the square root of the area. The square root of 124 is 12, and then label it as feet. Oh, and I forgot to label here. This would be inches, and this would be feet up here. And that's our learning target for the day. So again, let's just review it. Your learning target is you can evaluate square roots. Evaluate means figure it out. And we evaluated with a geometric connection there. And we evaluated with fractions. And we did a normal evaluation. That's it.